My name is Harvey Miller, and welcome to the third installment of our chapter on supply chain management. And in this third and short installment, we will look at supply chain analytics. In other words, how do we measure the performance of our supply chain? How do we know that we're actually doing the best that we can do with the current supply chain infrastructure that we are working with? And so let us take a look at some ways of measuring performance for the supply chain. All right. So we'll talk a little bit about a few things such as evaluating the supply chain, evaluating a sort of a disaster risk, understand the concept of a bullwhip effect, and supplier selection analysis, and so forth. Okay. So let's start off with this concept of evaluating a disaster risk. So supply chains are subject to many possible disruptions. And so if you wanted to get a sense of what the risk of a disruption is, you could actually do a numerical analysis of that, but also use it in a decision structure where you might be considering a single or multiple facilities, in which case you want to do the analysis to determine what the impact would be if you went for one or multiple facilities. All right. So for a given supply cycle, we have n suppliers, and there's a potential that these n suppliers can be disrupted. So we have S is the probability of a super event like a hurricane or a tornado that could disrupt all suppliers simultaneously. And then the probability of a unique event is U, that would disrupt only one supplier. It could be a power outage, at that particular plant, or something, So if we think of all the possibilities of a strike could cause a disruption, so those would be unique events and so on. And then the financial loss occurred in a supply cycle if all of the suppliers were disrupted. Now, why we say all of the suppliers and not just one is because if you have multiple suppliers, you're hedging against those risks. And therefore, if one supplier has an issue, the other suppliers are going to help you. So that's why, to get the sort of major effect on the organization, you would have to have all the suppliers actually not functioning. All right. C is the marginal cost of managing a supplier. Here we go. So you have a portfolio of suppliers and you want to balance your cost and your risk. So evaluate 1, 2, or 3 suppliers using a decision tree structure. Keep in mind that S, which is the probability that we said of a super event during the sort of supply cycle. U, the probability of a unique event is 4%, but only 0.05% for a super event. And then, of course, the marginal cost of managing a supplier is $10,000. The loss is $10 million if all the suppliers have gone down. All right. So let's remember the formula. The formula is the probability of a super event times 1 minus the probability of that super event times the probability of all of the units or suppliers being interrupted at the same time. All right. So essentially, what you're looking at with this part of the formula is the joint probability that there is no super event and all of the units actually are disrupted at the same time. So what's the probability of no super event? If the probability of a super event is S, then 1 minus S is the probability of no super event, right? So that's what we're looking for, probability of no super event and all suppliers disrupted from unique events. from a unique event. Alright? So if we treat those as independent of each other, we just multiply them. So u to the power of n. And so that's where this comes from. Alright? Okay, so we're back to our formula. So if we're talking about a single supplier in this case, then this is the probability of just that single supplier being interrupted. So it's the probability of the super event times 1 minus the probability of the super event times the probability of a unique event. Right? And so that gives us a probability of 4.48% here. If we're doing it for 2 suppliers, then we have the same probability of a super event, 1 minus the probability of a super event times both of the suppliers being impacted at the same time. So if both of them are impacted simultaneously, it would be 0.4 times 0.4. That is the probability of both of them happening at the same time, and that there's no super event. So that gives us a probability of 0.006592. So of course, as you increase the number of suppliers, the risk is actually reducing. The probability of getting this disruption is going down because you now increase your number of potential suppliers. And the third one should be even less, because now you have 3 suppliers. So it's the probability of a super event, 1 minus the probability of a super event, times the probability of all 3 suppliers being disrupted by a unique event, which is 0.04 cube. And that gives us this value right here. So now let's put that in the form of a decision tree. What does a decision tree do? So we have this decision point right here, and we have 3 possible branches that we could go through. Either invest with 1 supplier, 2 suppliers, or 3 suppliers. Alright? And then look at what the cost is of those 3 situations right there. The way in which we're going to make our decision is on the basis of what we call the expected value. Of the costs, or the losses, we should say. The expected value. So, if we take this route right here, the very first one, that's the way a decision tree is structured, is that you make a decision and there are possible outcomes. And let me just go back here for a second and introduce this. So, you have a decision tree, you're making a decision, then you have possible outcomes. In this case, 2 possible outcomes. Super event, no super event. Right? So the decisions are 1, 2, or 3 suppliers. So essentially, what you want is the probability, of that one supplier going down. So here would be 1 minus the probability of that supplier going down, right? P2, 1 minus P2. Because remember, the other branch is just the complement. P3, 1 minus P3, and so on. So if we now take that and multiply it by the consequence, and then we add them up, then we will get the expected value of this node. The expected value of this node and the expected value of this node. Alright? So we have to multiply each of them by the respective consequence. And the one that is, since we're dealing with cost or loss, the cheapest one is the one that we will keep. Okay? So let's see what we have here. I had it the other way around. P1 and 1 minus P1, they have 1 minus P1 and then P1. So 1 minus P1 means that there's no event that happens. Alright, no disruption. And so with no disruption, what we have is that you just have the cost of the marginal cost of managing 1 supplier. But if there's a disruption, then you have your loss of 10 million plus the cost of managing one supplier. So you have that information right here, but you must now multiply it by the respective probabilities, and then you will get, so in other words, this value of 458,000 here comes from multiplying 0.9552 by 10,000 plus 0.0448 times the 10 million 10,000. Right? So if you add that together, you get the $458,000. You repeat the process now for 2 suppliers. So at least one of them fails, where you will have, if one of them fail, or sorry, not at least one, less than one or less fail. That means you have at least one left. So if you have 2 suppliers, one or less fail. Either none of them fail, or you have one fail, but one is still working. All right, and then the alternate branch is that both of them fail. Right here, both of them are failing. So the complement of both of them failing is that one or less fail. All right, and then we do exactly the same thing here. Calculate our expected value and the expected value. So in this case, when you look at the expected values, this option has the cheapest cost. So it would be recommended that you actually have 3 suppliers for this particular situation. All right. Let's talk a bit about this concept called a bullwhip effect, which is something that supply chains have to manage quite effectively, because it can lead to increased costs in the supply chain. And what causes that bullwhip effect? So if you think about a bullwhip, if you flap a bullwhip, what happens is that you see up close to your hand, you have fairly high amplitudes, and then as it gets towards the end, it trails off. Well, what happens is in a supply chain, each stage is dependent on the next stage for information. So your suppliers, your retailers depend on your suppliers in terms of their purchase, the demand. Then the distribution center, relies on the retailers, and then the manufacturer is relying on the distribution centers. Then the supplier is relying on the manufacturer. So you can see what happens now. If you make a mistake at the very front of that supply chain, it basically escalates as you go back into the supply chain, and hence the sort of the increase in the amplitude as you get towards the supplier, and that's called a bullwhip effect. And you have to, it's important to try to manage that, because it can actually drive costs in your supply chain. One of the things that could cause a bullwhip effect is companies that have, like, for example, sales, trying to get rid of things, right? Now, it could be that the demand is low, but because you actually cut the price by half, all of a sudden, a whole bunch of people came and bought the product. So it looks like your demand, if you are not separating past demand from that sales event, you might actually treat that increased demand that you just saw as the actual demand. Well, if you now are going to look at that and treat it as if it's actual, you will place your orders based on that amount. So all of a sudden, your distributor said, oh my God, the retailer has just ordered a huge amount. So now they're changing their calculations, saying, whoa, things must be pretty good at the retailer. And so we need to up our ante and increase our our orders from the manufacturer. The manufacturer now sees a bigger order coming from the distribution center, says, whoa, look at that. I'm going to have to increase my manufacturing output. So as you can see, it starts to spiral back, and then incur fairly large inventory levels, and that cost gets passed on to the consumer. So there's a need to optimize the supply chain, and the way in which you can do that is to share information. So the tendency for larger order size fluctuations as the orders relay through the supply chain. It creates unstable production schedules, expensive capacity change costs, underutilization, longer lead times, obsolescence. Now, what tends to happen with the bullwhip effect is that after the sale has cooled down and then the demand drops again, now the retailer is ordering a smaller amount. So the manufacturer says, oh my goodness, look at this smaller amount. I'm going to now drop my my order to the manufacturer. Manufacturer now sees a smaller amount, and so as you can see now, it's time to trail off, right? So damage can be minimized with supplier coordination and planning. So if the various people in the supply chain are actually sharing information in terms of what's real and what's not, they could actually mitigate against the bullwhip effect. All right. So that's what you're seeing here. You see, this is the handle, and then it starts to taper off eventually. Okay. So that's kind of the bullwhip effect. How can you manage it? By having better forecasts, reduce your forecast errors, order batching. And these are things that actually cause it. It's forecast errors. But so if you try to reduce your forecast errors, that would certainly help. When you batch orders and then you create large orders, and they're infrequent, then the upstream provider is trying to second guess what your actual demand is and could end up overproducing. Price fluctuations when you're offering sales and so on, discounts that could cause problem, and sometimes gaming, hoarding supplies for fear of supply shortage. Well, if you're hoarding supplies, then you're placing larger orders so that you can keep it just in case of a potential shortage, in which case you are miscommunicating what the true demand really is for the product and so on. So there are some suggestions. You could share information. You could do better coordination across any distribution channel so that you have constant, as much as possible, sort of lot sizes that make sense, that make economic sense, but you don't fluctuate them too much, right? And then do price stabilization. Keep your prices stable so that way you don't have these radical fluctuations in terms of your demand. So everyday low prices, which is what Walmart sort of uses, that definitely helps it to stabilize the demand for its products. And then allocate orders based on past demand, not demand that is created by sales discounts and so on, but rather on actual demands. The bullwhip effect is really can be measured as the variance in the orders versus the variance in the demand. All right. So what tends to happen with the bullwhip effect is that the amount that you order is inflated relative to your demand, and so therefore this will tend to have a value greater than 1 when you have amplification is present, in which case the bullwhip effect is present. All right. And this is just an example that just shows. Here's an example of one firm, and you have the retailer, Furniture Mart Inc., but gets its products from a distributor, which then gets it from a furniture manufacturer, and then these are the raw material suppliers, and then you could see the variance of the demand versus the variance of the orders. So if we put the variance of the orders over the variance of the demand, we get the bullwhip measure. And as you could see, is 1.10, 1.64, 1.67, 2.5, 2.67. So it's actually increasing as you go down the list. Okay, as you go back towards the suppliers, the bullwhip measure is actually increasing. How do we select suppliers? Supplier selection will depend on a number of factors. And so, cost, location, reliability, quality, all these factors are important. So Nowadays, people don't just choose a supplier based on who can give me the best price, but who can meet a number of criteria. So there is a technique that we call factor weighting, which is basically identifying all the key factors, weighting them, and then assessing each vendor to determine what their weighted score is, and then you pick the vendor with the best weighted score. All right. So if you were looking at an example, two companies, this is called Faber Paint, Smythe Die. Well, what are the factors being considered? Engineering innovation, production processes, capability, distribution capacity or capability, quality, performance, facilities, location, etc., etc. So you have all of these criteria. They're given weights that add up to 1, and then the highest possible score is a 5. So you score each of these companies on the basis of their performance on these different criteria. Then you take the weighted value in the end, all right, and then based on the weighted value, then you compare them. So the weighted score for Faber is 3.9. The weighted score for Smith Die is 4.2. They're relatively close, but then you could decide if you're going to just select the largest value, then you would select Smith or Smith Die. Yeah. Here's a case now where you have an option to consider two transportation modes or two shipping modes. So you're shipping a product called connectors from one location to the next, from San Jose to Singapore. Each connector costs $1,750. The holding cost per year, that means the cost of keeping the item in inventory, is 40% of its value. So 0.4 times 1750 is the holding cost. All right. Now remember, that's holding cost per year. So you could actually compute a holding cost per day if you wanted to. So if I divided that by $365, I would get a holding cost per day. Well, what's the holding cost per day for this? It's going to cost me $1.92 to hold that item per day. All right. Now, it turns out that one of the two carriers, right, can actually get the product there a day faster. Is it worth it? Well, you say, if you can get it there a day faster, it means that I'm incurring holding costs for at least one extra day. So let's see. If compared to the one that could get it there a day faster, I would save 1 day of holding costs. But at what cost would I save that 1 day of holding costs? Well, it turns out that you would save $1.92, but it's going to cost you $20 more. So what would you do? Clearly in that case, the 1 day faster is not worth it. It's more expensive. So when you compare the 192 to 20, choose the slower shipping, the one that actually will take 1 day longer, because it will be cheaper for you, all right? By approximately $18.08 or something like that. So it's really not a big deal. Okay. So finally, we'll end by looking at the topic of warehouse storage. How do we store items in a warehouse? That's also part of supply chain management. You have to store things in a warehouse so that there are all sorts of criteria that you would consider. You want to minimize damage, the risk of pilferage. You want to make sure that it doesn't take too much work to store the item and then retrieve it. Okay, so particularly if you have a lot of movement or a lot of volume or velocity, what we call velocity, with respect to a particular item, then if you're going to be going and retrieving that item multiple times a day, you don't want that to be way in the back of the warehouse. You want it to be up front. So this helps us. We're going to talk a little bit about how you store products in a warehouse relative to that. But there's so many factors that are involved. If it is some warehouses are zoned, if there's cold storage, you could put cold storage. items right here, bulk items in this location, etc. Kitted items. When you say kitted items, items that belong to a kit. There might be 5 items that form a kit, and then you put those in a special location. So there are multiple factors, right? But it's very important that you have a good warehousing strategy, because it could actually drive up your costs as well. So storage in a significant step is a significant step for many items. So you determine which items to store in which locations. An order placement improves efficiency and saves time. So where you put the item in the warehouse will help to improve its efficiency. Imagine if you have a dock here where products come in, right? And then you have these 16 locations, and you're trying to determine where to place those. This is just one criteria. So you could actually look at it on the basis of the number of trips per area. So if you call these blocks, right, or that's a block, so these are all blocks, right? So how many blocks you're going to allocate to a particular item, and if you look at the average number of trips to those areas, that helps you make a decision. So what you do is you look at the number of trips that will be made, right, monthly, and the number of blocks needed to store the item. So if we divide the 600 by 5, then we will get essentially the number of trips per block. All right. So if we get the number of trips per block, what you want to do is the ones that we prioritize those that have a lot of trips, because that's a lot of movement, and so therefore you want them closer to the dock. So as you can see, light bulbs, you're going to need 220 trips per block. That's the highest, so therefore you put that in location 1. You want to put it close. And then you have this next one here, small hardware. Small hardware requires 2 locations, remember, and it is ranked second, so you could put it in 2 and 4, right, and so on, and then you continue. So now this one over here, 130 requires so that's the next highest value, requires 3 blocks, so you could put it now in 3 and 5 and so forth. So that's kind of how you would go about doing this until you've assigned all the blocks, and you can see the assignments right here. Okay, so we have now come to the end of our chapter on supply chain management. As I mentioned to you at the beginning, that supply chain is a very important topic. It has strategic implications for any firm, whether or not you are for-profit or not-for-profit firm, because it basically drives up the cost associated with delivering that product or service to your customers. If you are not-for-profit, you still want to minimize the cost, because often not-for-profits have very tight budgets, so therefore they want to minimize their operating costs. But at the same time too, they want to deliver quality, they want to be responsive. So if you want to do all of those things, you still have to manage the supply chain effectively. You still have to look at things such as how many suppliers should I have, where should they be located, how do I structure the supply chain, right? Same thing for for-profit organizations. Depending on how the firm decides to compete, if it wants to compete on low cost, it has to find low-cost suppliers. If it wants to compete on speed, it has to find suppliers that could be very responsive. And then if it wants to compete on differentiation, it has to find suppliers that can innovate their products in a very quick manner of time. All right. So all of those things are quite important, and we saw the importance of supply chain management during the COVID pandemic, when the supply chains for all sorts of products were interrupted, and we saw shortages, and then we saw price gouging that happened because supply and demand. If there's a lot of demand and there's no supply, so what do retailers do? They raise the prices. So we've seen a dramatic increase in the price of things like lumber, for example. That was one of the areas that quickly went up in price. during the COVID pandemic. So, but there were many others. Food items, hardware, all of those sorts of things. Equipment, generally speaking, went up significantly during COVID. So we saw the importance of a supply chain, and that is not going away anytime soon. So it's extremely important that anyone who is studying operations management understand the importance of a supply chain.